Hi, my name is Nurul Aqilah binti Muhammad Syafi'i. Here, I will share with you about the main element groups, which is group 17. Group 17 also known as halogen groups. Okay, so let's start. So, firstly, what are the elements of group 17? As you can see here, group 17 consists of 5 elements, which is fluorine, chlorine, bromine, iodine, and astatine. Next, what are the state of matters of halogen elements? Liquid, solid, or maybe gas? At room temperature, group 17 contains all state of matters. First, fluorine exists as a pale yellow gas. Meanwhile, chlorine is a light green gas. Bromine is the only in group 17 element exists as liquid, and iodine appear as a purple solid. The last element, astatine, exists as a black metallic solid and also one of a radioactive element. Periodic trends in halogen groups. For melting point and boiling point, it's increasing when going down the group. And also same as for atomic radius. Meanwhile, electronegativity is decreasing if we go down the group. So do electron affinity and ionization energy. The reactivity of elements decreases down the group. This is due to the fact that atomic radius increases in size with an increase of electronic energy levels. This decrease also occurs because electronegativity decreases down a group. Chemical reaction involved with halogen elements. First, reaction with water, H2O. Okay, so let me tell you what will happen if halogen element react with water. Fluorine. So here is the balanced chemical equation. Fluorine reacts vigorously with water. Sometimes, instead of oxygen, ozone is produced. Fluorine may not seen in laboratory since it is very reactive. The second element, which is chlorine, which is moderately soluble in water. In this reaction, it produces hypochlorous acid, HClO. For bromine, hypobromide ion, Bro- will form. Meanwhile, for the last element, iodine, it is slightly soluble in water and cause reaction occurs very slowly. This reaction produces hypoiodous acid. Okay, now we move to the second reaction, which is reaction with hydrogen H2. For fluorine, when hydrogen gas reacts with fluorine gas, it will produce hydrogen fluoride. This reaction combines explosively with hydrogen even in the cold and dark place. Chlorine, when we react the hydrogen gas with chlorine gas, hydrogen chloride will produce. Chlorine and hydrogen can explode if exposed to sunlight or flame. Meanwhile, for bromine, hydrogen gas react with bromine gas, hydrogen bromide will be formed. Bromine vapor and hydrogen combine with a mild explosion if comes into contact with flame. And lastly, for iodine, in this reaction will forming hydrogen iodide. Hydrogen and iodine combine partially or even on constant heating. The bond strength of these hydrogen halides are decreased down the group. The bond strength of HF greater than HCl, HCl greater than HBr, and HBr greater than Hi. Then, we proceed to the next, which is reaction with metals. Okay, we start with alkali metal from group 1. The first fact we should know is all alkali metal react vigorously with halogens to produce salts. For example, we take for sodium chloride NaCl and potassium chloride KCl. NaCl and KCl are commonly used in industrial. NaCl used as a preservative for meat, however, it's used in daily life like cooking. Meanwhile, KCl is important for plant fertilizer. So here, I show you a simple chemical equation for sodium chloride where sodium solid react with chlorine gas. Next is the reaction with group 2 elements. These alkaline earth metals react with halogens to form hydrates halides. In second point, beryllium is the exception because it is the least reactive element in group 2. So this is the general equation for group 2 when react with halogens, where M represent element from group 2 and X represent halogen element. Okay, the last reaction in this video is the reaction of halogen with iron wools. Gold iron wool burns in cold fluorine to give white iron trifluoride. This is a rapid reaction in which the iron burns and is oxidized to an iron 3 compound, in other words, from an oxidation state of 0 in the elemental metal to an oxidation state of 3 plus 3 in the iron 3 compound. Next is chlorine gas in contact with hot ions to produce orange-brown iron 3 chloride. The iron is again oxidized from a state of 0 to plus 3. Bromine vapor passed over hot iron triggers a similar, slightly less vigorous reaction which produces red-brown iron 3 bromide. Last but not least, the reaction between hot iron and iodine vapor produces grey iron 2 iodide and is much less vigorous. Iodine is only capable of oxidizing iron to the plus 2 oxidation state. I think that's all from my video regarding group 17. I hope you enjoy my video and thanks for watching it. Watch more, listen more and understand more.